Mbak, ready? Kita masih bisa. Soalnya dah pagi kan. Radio ni.
Respondents are 100 friends, and during the session, sharing session, the participants can still fill in the form, and hopefully everyone take parts in the fill in the form. Okay.
So, ladies and gentlemen, our morning workshops will continue with an insightful sharing sessions. But before that, allow me to introduce our esteemed speaker. Assistant Professor Dr. Pratchayapong Yasri is from Science and Mathematics Education, Faculty of Science from King Mongkut University of Technology, Thonburi, Thailand. Now, without further ado, we would like to invite our guest speaker, Assistant Professor Dr. Pratchayapong Yasri, for the CER model sharing. Please welcome.
Thank you very much. Thank you for lovely introduction, and very nice to see you all virtually from Thailand to Malaysia. So let me share my screen. Right, and I hope you can see my screen and the QR code where you can download my slide. So if everything okay from that side, can you let me know so that I can proceed? When I put it all the full screen, I just can't see the camera from that side. So I can I see the sign? If everything okay when I share the slide on the full screen, so you can see everything clearly, so that I can switch to the full screen and I won't see the camera from your room. Okay, thank you very much. Thank you so much for that strong confirmation. Okay, so let me start. Good morning, everyone, once again. It's such an honor to be invited by CER exam today to be sharing with you insight on three-dimensional learning and the CER approach that we are currently implementing under the project called Southeast Asian Teacher Education Program, or CTEP. And yeah, my name is Pratchayapong Yasri from King Mongkut University Technology, Thonburi, Thailand. And so let me begin our discussion today by introducing what we are doing under CTEP. So basically, CTEP is a movement from CER STEMET, CER exam, and other partner countries like Cambodia, Indonesia, and also Kazakhstan. So the aim of this movement is to equip teachers with skills and practices in order to deliver um, STEM education with high quality. So just before we start, I would like to learn from you. I would like to get to know you more, and I would like to get to know, what you think about ideal education or ideal classroom. So let me kick off by having this short activity for you all to discuss, and I may want, to ask one or two from you to help me clarify what your answer is. So here is the question using the analogy of Magnum, the ice cream on the left, and Sunday ice cream, which is on the right. So, using the analogy, my question is that if you're thinking of an ideal classroom in 2025, which type of ice cream you are going to pick and why? So basically, it's the analogy, and I would like you to discuss and share why do you think ideal classroom should be like, a Magnum, or ideal classroom should be like a Sunday. So I will leave you 2 minutes to think and discuss in your rooms, and then I will ask, one or two of you to share what you think. So I just try to make sure that you help discuss when you think of an ideal classroom. So which one in particular that you think you want to um, have, and maybe you want to explain why do you think an ideal classroom should be like a Magnum, or an ideal classroom should be like a Sunday, and why? So just would like to learn from you. Can I have one person from I don't know how to call the room, but can I have one teacher, please? Anyone at all? Anyone would like to share what you think about ideal classroom that we should have? If it is going to compare to either Magnum or Sunday. Yeah, I can see clapping, but I'm not sure. Yes, okay, I can hear the voice
Morning,
now.
doctor.
Good morning. Thank you very much
Actually,
for
my name is
participating.
Mohammed Hazri. You can call me Hazri. Actually,
Hazri.
I like Magnum ice cream rather than Sunday ice cream, because for me, I like the chocolate and then the inside the creamer and nice. That is my reason, right? Is it enough?
Right.
And then the evidence is the what the no cholesterol no that one gelatin and one more ingredient of the Magnum ice cream.
Right.
Okay,
So
that
you
is,
like you like the chocolate, you like the vanilla inside. So
yeah.
can you help compare, what you like in Magnum to classroom, and how do you want the classroom to be like? For example, what you
One
think of
more
the chocolate part?
One more Magnum is a branded ice cream. That's one. I like branded. Yeah, that's another reason. All right.
Right. Branded ice cream, right?
Yeah.
So the either classroom has to be branded. Everyone has to know what the classroom is like. So yeah, Magnum, wherever you sell it, it's going to be exactly the same, right?
And
Thank you very much.
thank you, doctor.
Thank you.
Thank
Can I have
you.
additional thoughts?
Next.
Can I have Magnum team? Magnum team.
Yes.
Yes, please go ahead.
Hi, doctor.
Good morning.
Good morning. I'm Shazwani. Oh, sana. So this way. So I'm Shazwani, lecturer for Maths. So from my opinion, an ideal classroom in 2025. So from my point of view is Sunday. So I just start with this.
Interesting.
Okay.
Mhm.
So the reason is that um, in a Sunday ice cream, so if you have you can put anything on it. So for example, if you love cherries, you can put cherry, you can put sprinkles, you can put chocolate sticks or anything that we want. So
Mm.
it's more viable from my opinion. So with the link for the class, I think I like my class to be more cheerful, more colorful, something like that. That's
Okay.
why I chose Sunday.
Thank you very much. Thank you very much. So I think what I can summarize from your sharing is that probably an ideal classroom is, a personalized classroom where the Sunday ice cream, you can put whatever you like, or you can put, whatever the customers like, and then you can personalize it to best fit to the customers. Thank you very much.
Okay, thank you, Doctor.
Okay, thank you very much. One last idea, please. One last idea. Can be any CER talk, can be Magnum team, or can be Sunday team.
One more, last. One more.
Sorry that I get you to work in this morning. I just want to make it interactive. So hope you don't mind. So we have one idea from Magnum, which is, a branded classroom or a classroom that is, um, you know, reach the same standard. Wherever you go, you can reach the same, standard of ice cream or standard of classroom. And you have a more personalized classroom representing from Sunday ice cream, where you can, customize the class for students. So maybe another person can help me, wrap up. Could be either Sunday or Magna. No. So if no additional thought, I can continue the discussion today. Right. Okay. So if no additional thought, thank you very much for two perspectives. And I think I fully agree, with both of you that Magnum ice cream is representing, the same standard that we would like to achieve, the same goal that we like to move forward. And whenever we have our students learn something, there shouldn't be any disparity of standard, right? So every corner, every school has to meet the same standard. But in the same time, we need the flavor of Sunday ice cream, and that is personalization of classroom to make it fit our students. Because the same learning approach may work in one classroom, but might not work in the others. So adopting both of these perspectives together, I would like us to keep this in mind, that we would like to have the same goal of Magnum to reach the same standard, but we know our students the best. We know how they learn. We know what work best in the classroom. So I would like to continue what I uh, see as the growing concern in Thailand, and that is to do with the PISA performance across all areas, like reading, mathematics, and science. As you can see from the data, Thailand is actually, score pretty low, and it is in the declining trend over time. And this is actually highlight the urgent need to rethink how we can approach learning and teaching in our schools. And if we continue to do the same thing, if we continue with traditional methods, students may struggle to apply the knowledge in real life phenomena. So what Thailand has been doing though Thailand has been, doing the way to solve the problem by having something like, PISA team to address educational crisis and what, the team is trying to do. I'm not saying that it doesn't work, but, it may work in short term that to help students do some tutoring of PISA exam and to know how to, address all the questions in the PISA exam. But for me, uh, if the goal is to only train students to take the test better, I think we still risk missing the bigger picture. And that is how to develop real critical thinking, problem solving, and scientific literacy skills among the students. And I think that is what PISA is actually wanting to see our students to perform, not just only to be able to do the test, but able to do the tasks of the scientists. So just before I start deeping down into 3D CER as topic that I'm doing today, I want to use this analogy to take a moment for you to reflect on the statement that I put in here. I said that to change the goal is to transform the means. So what does it mean to me in terms of education? So imagine there are two ways to travel, right? So if I set the goal to Pattaya, I'm in Bangkok at the moment. So Pattaya is only like 1 hour and a half away from where I am. So if my goal is to reach Pattaya only, I think the means for me or the vehicle for me to go is just a private car, just a vehicle. I think this can get me there surely. But if I change my goal, I have a bigger goal. I have a bigger picture. I have a bigger mission for me to continue. For example, if I want to go to Malaysia, of course, if I do drive, it may take me days in order to get there from Bangkok, and it might be very tiring. The journey might be very tiring. So if I change the destination, I change the goal, this will, prompts me as, a visitor to change the mean what I'm going to take in order to go to Malaysia. And I think that a car might not be practical. Then I think taking the plane, taking the flight might be a more suitable option. And I think the same is true with education. If we continue to use the same goal, an easy goal, an easy goal to achieve, I think teachers don't have to change the way for them to do much, as they can simply reach what is set for them to do. But if the goal is becoming more challenging, I think the means is going to be transformed, and that is what I would like to start with, transforming the goals with thinking about learning triangle. And then after we reach the agreement to what extent how the goals can be changed, I think we can continue with the means, and that is three-dimensional learning and CER. So these are going to be three main topics that I'm going to cover today. All right. So the first one is about learning triangle. So basically, learning triangle is the concept that highlights relationship between three significant elements in education. The first one is learning outcome. The second one is learning method, and the third one is learning assessment. If we put this into the analogy that I have just put earlier, so the learning outcomes or the learning goal is the destination that we want to go, we want to reach. So basically, it's measurable statements that define what learners should know, or for them to be able to do after the learning experience. But how are they going to achieve that goal? It is the method that they are going to use in the classroom. It's the learning approaches that the teachers will execute in the classroom, or it's the means that help travel them to the destination. And the third element is learning assessment. The learning assessment basically is the way for teachers to check whether the learning outcomes are achieved, whether the learning methods being implemented are actually working, right? So I know that I'm talking to experienced teachers at the moment, but just to discuss with you again. So I just would like to change the dynamic from me talking to you sharing, and then we learn from each other. So I just want to sum up that there are frameworks, there are theories that we can use to formulate learning outcomes. There are various learning approaches that we can adopt to run learning activity in classroom, and we have several ways to do learning assessment. For the learning outcomes to be set, I think we are familiar with the one on the left hand side, that is Bloom taxonomy, and we know that the higher the level, the higher.
Sorry, Doctor, for interrupt.
Yes.
Your slide is not moving.
Oh, my
Yes.
slide is not moving. Where is it now? It's to stay here. Can you see the slide?
Yes. Okay.
Does it move now? It's slide number 9.
Slide.
Is it number 9 on
Can
the
you
bottom right?
Full screen. Can you full screen the slide?
Let me
Slideshow.
let me fix it again. Let me do entire screen so that we make sure the problem is solved. Does it work now?
Okay.
Right. So you can see slide number 9. Where
Yes.
did I stop myself? Where did I stop myself?
Slide number 9.
Okay. Right. Okay. Yeah. Right. For slide number 9, that there are several theories that we can adopt in order to formulate learning outcomes and to choose learning method and also learning assessment. Right. I just provide some examples like to set the learning outcomes. We can use Bloom taxonomy, which is on the top left, or we can use 21st century learning skills on the top right. Or I will talk about PISA competency and three-dimensional learning later. And of course, I know that mathematics teacher are with me today. I include mathematical reasoning, which is also the framework from PISA. So these are the learning outcomes that we can formulate, and there is a range of learning methods that we can adopt, right? Ranging from lectures, interactive lecture, group discussion, hands-on activities, and a range of based learning like inquiry, project, problem, or flipped classroom. And we have variety of learning assessment like test, discussion rubrics, observation rubrics, and worksheet. Okay. Now I would like to do some activity again with you, that I'm going to show you learning outcomes or learning goals one by one. And I just want you to have a think. If I have this particular learning goal, what learning method and learning assessment that I have to adopt? The assumption is that if I have a learning goal appearing on the screen, I would like you to think from the perspective of a less keen teacher. You can see the teacher on the bottom left. I don't want to call him a lazy teacher because he isn't lazy, but he is, a minimal teacher. He's a less keen teacher. If you want him to go to Pattaya, he will just go to Pattaya. If you want him to go to Penang, he will just go to Penang. If you want him to go to Kuala Lumpur, he will just go to Kuala Lumpur. He is not going to go, further than what the goal is set. So what I would like you to do is just to think of, learning method and learning assessment that actually can bring you to achieve this learning goal. So let me start with the first one. If I would like the class to be able to explain, principles in biology, like Mendelian genetics, for example, dominant and recessive traits, genotype and phenotype. If you don't know these terms, if these terms are, unfamiliar to you, just ignore them. But the purpose is for the class to explain the biological principle. So what learning method and learning assessment that you think this less keen teacher can do. Can I have one person answer, please? Can be anyone at all. I just want to change the dynamic from me talking to you sharing.
We would like to invite the biology lecturers. Any biology lecturers?
I'm sorry, I'm not quite following that. I'm not sure if you are answering at the moment.
Doctor, wait a
Yes.
second. The lecturer biology is discussing among them.
Oh, I see. Okay. Right. So just imagine, you don't have to be too creative. This teacher that I would like you to imagine is a less keen teacher. He is not that enthusiastic. If the goal is for students to explain something, just go for a minimal approach.
Please, biology lecturers. ChatGPT je, pakai ChatGPT je, bukan bio. Alah.
Right. Very exciting to learn from what you have discussed.
Yes, thank you. Welcome. One Sharon.
Yeah. At least they can hear the clap.
Hello, hi, doctor.
Hi.
Okay, my name is Shaira binti Azaman. If you look at the question, this is a very long essay question, isn't it? Okay, so we have to explain about the principles of the Mendelian genetics, and then we have to explain about the dominant and recessive traits, genotype and phenotypes. So I think for the Mendelian genetics only, that one will includes about 10 marks question for us lah. Okay, so this is for Mendelian genetics. Actually, we have a monohybrid and dihybrid inheritance. Okay, and then for the monohybrid inheritance, we have the what is that? The ratio, the phenotypic ratio, and then we have the genotypic ratio. Okay,
Right.
Dominant and recessive traits. Okay, the dominant traits is the phenotype lah, physical appearance. Okay, the dominant traits is the traits that can be expressed in the homozygous or heterozygous genotype. Okay.
Right. Thank you very much for
Right. That's why
helping
I say
explain
that
this.
is a very long.
Yeah, but can just continue with me. The purpose is not to explain though. This is the learning goal that imagine we are the teacher and we would like to let our students achieve this goal, right? For them to be able to explain. So can you suggest what learning method that you think we can use in order to help our students understand and then they can explain this concept?
For biology, actually, we use the mind map. That is the the mind map. Also, this is the Mendelian inheritance. So for the genetics topic, we actually use the genetic diagram. Okay, we use the diagram. Okay, lots of diagram. Of course, biology includes lots of diagrams. And also this is also involving a few calculation.
Right.
Okay.
Right. So So depending on the subtopic, right? And then you can use various approaches in order to execute the classroom activity. Thank you very much. Thank you very much for your contribution. Yes, we can see that experienced teachers can be flexible in adopting various learning approaches or learning methods to help students learn to achieve the goal. But if we only want our students to understand and explain what they understand, I think that good teaching is more than enough. Lecture is more than enough. If it is explained well enough, I think students will be able to understand. And if they if they are able to understand, I think it's possible for them to explain that. And how are we going to you know, be sure that our students can actually explain? We can use some quizzes, we can use, tests for students to do. So as I said, we can do a lot better than this, but this is, for the imagination of a less keen teacher who just would like to achieve this goal. So this happens in Thailand as well. It happens in the I think in many places, that if we have a less challenging learning goal, it's likely that teachers will find a more comfortable way to deliver the content in the classroom. And I think that lecture is something that teachers may think that it's in control. They can plan, they can think, they can decide. It relies on them, delivering the message. Like what we are trying to do at the moment, apart from technical difficulty, discussion can be more challenging than just lecturing. And I think the same is true in classroom. If we only set the outcome for students to explain, so a less key teacher can just use one way communication through lecture or interactive lecture to execute that. And quizzes, tests can be appropriate method to assess student learning progress. What if I continue? Still, I'm a less keen teacher, but I change the learning goal from explaining something to engaging in discussion, to let students discuss about Mendelian genetics. And after the discussion, I let them, explain and articulate the implications of genetic principle in real world context. So if I use these learning goals, the learning approaches, learning method has to be changed as well. And I think only one way lecturing isn't enough, because the learning goal is set for students to engage in discussion. So there must be some form of interactive lecture and discussion in the classroom. And if I change the method, the learning assessment has to be altered in some way. Of course, I still can, use quizzes or tests, but quiz and test may not reflect, how well students discuss in the classroom. So I will have to do something extra. For example, like, using discussion rubric or reflection essay for students to write, or, for them to explain what they learned from the class. And from explaining to engaging in discussion, what about I continue to the third one? And the third one is for students to investigate the inheritance of trait through experiment to understand that concept. Okay, and then after they understand how dominant and recessive alleles, what they are, and then understand how they contribute to genetic diversity. Again, I'm not trying to make this one specific to a particular discipline. It is just an example. But the third one is for students to investigate, to do some experiment, and then use the knowledge from the experiment to contribute, to explain something further. I think this teacher, if he wants to meet that goal, he has to change. Lecture isn't enough. Discussion might not be enough, because the goal is for students to investigate. So there must be a form of inquiry-based learning. There must be a form of hands-on activity in the classroom. And of course, the learning assessment has to be changed as well. So this can be in the form of presentation, or can be, a lab report from the students. From explaining to engaging in conversation, in discussion, to investigating an experiment and then to understand. I think we can even go further. And this is, the encouragement that I would like us all to go further. What about this? If we have the goal for the students to be able to conduct a genetic analysis in order to gather evidence and then use this evidence or use this data to construct an argument. So there are two things they have to do, right? The first one is to conduct an experiment to gather evidence, and then to use the evidence or use the data to construct an argument. And the argument has to explain exactly the same thing with the first learning objective, that is to explain the role of dominant recessive alleles in determining phenotypic traits in organism. So in the first classroom, for students to be able to explain this concept, they can just learn from textbook, they can just learn from the slides of the teachers, but the skills for acquiring that knowledge or that fact might not be cultivated in the classroom or among them. But if the learning objective has been changed for them to conduct an experiment in order to collect the evidence and use the evidence to construct an argument that explain the concept, the students will be empowered with knowledge development, constructing explanation by themselves, not just only learning from the textbook, not just only understanding science as something ready to consume, but it's something that they can continue to develop their understanding. And of course, learning methods and learning assessment have to be changed as well. The teachers are going to be busier, like preparing hands-on activities, having the argument construction, exercise in the classroom to let students practice. Somehow they have to conduct the experiment in group to be able to score argument from the students. Then argumentation rubrics have to develop, and of course they have to prepare the worksheet for students to fill in. So as I proposed earlier, that if we change the goal, we are going to transform the means, right? So this is the first key message that I would like to encourage all teachers that I have opportunity to talk to, that we are not going to place there. If we are looking at us who are executing classroom activity and we want to play safe, we want teachers to just do what they are comfortable to do. They can keep the learning goals simple. But if they want students to continue to grow their understanding, they have to first start from transforming the goal to something that we want our students to have that competency. And the goal that I would like to introduce, or in fact there are many learning outcomes or competencies that students can focus, or teachers can focus in classroom, right? But in Thailand, we are currently facing problems about our students' performance in PISA. So we encourage teachers to incorporate competencies in both science and mathematics according to PISA framework to help our students develop their competency. So on the left-hand side is PISA competency in science. On the right-hand side is competency in math. So I will just, briefly summarize what PISA science framework is like. So this one, there are three key elements of three competencies that students are going to be assessed in PISA 2025. The first one, the red color, it's to explain phenomena scientifically. So basically this one is not just only explaining or remembering from textbook, of course not, but there are steps for students to be able to explain. As you can see, number 6 is for students to explain, right? But for them to explain, it has to start from 1 to 5 first. So the first one basically for them to recall and apply scientific knowledge. And then to use different forms of representations in order to communicate their abstract thinking, and then they can make and justify appropriate scientific predictions and solutions. they can construct a model, they can identify, they can evaluate the trustworthiness or the validity of the models, number 4. And then number 5, they can recognize or develop, explanations by themselves. And then they can explain how the materials learned in the class can be linked to society as a whole. So the first one, the red one, is not only remembering facts from textbook, but for students to be able to explain that scientifically using various forms of representation. Can be physical model, can be formulation, can be formulas, can be graphical forms of anything that is representing what they understand. Let me continue to the second part. Apart from the red one, which is the competency to explain, the yellow one is the competency to construct and evaluate designs for scientific inquiry and interpret the data. So basically, it's for students to plan out what they are going to do, how they are going to find the evidence to support what they believe, and draw the conclusion based on the result that they get. And the last one is for them to be able to research, evaluate, and use scientific information for decision making and action. I know that we have computer science teachers with us today. There is a growing body of intelligence, artificial intelligence applications in classroom, right? But for students to be able to evaluate the credibility of information available on the internet, available or generated by AIs. So these are essential skills in this current era. So as you can see, the explain the phenomena isn't enough. Students have to be able to construct and evaluate, design, or investigate the experiment to get the evidence to support their claim, and then they have to be able to evaluate and use scientific information to back up their claim as well. So based on this, I think if the learning goals continue to be more advanced, from explaining to engaging to investigating something, to finally to conduct experiment in order to get evidence to construct their explanation, this is going to be the aim that PISA would like our students to perform. And not only science, if I turn to mathematics, again, it's not only ability to solve mathematical problems only, but it's mathematical reasoning that our students will have to be able to express. So basically, it's logical thinking that ensure reliable conclusions. So mathematics is a so much powerful tool to help our students to validate their claim. So basically, there are 6 key areas. So it's to do with understanding numbers and how they work, using symbols and abstract thinking, recognizing patterns and structure, identifying relationships between quantities, applying math in real life, and understanding variation in data. So these are the 6 key ideas for mathematical reasoning, and how mathematical reasoning is going to be sequenced in the classroom. From this framework, it shows that there are 3 interconnected stages. So the first one, student will have to be able to formulate. What does it mean by the term formulate? Is to identify and structure real-world problems mathematically. So when students see problems, they can turn the problems to mathematical ideas or to mathematical problems, and then they can continue to the second stage, that is to employ or apply some mathematical concepts or mathematical procedures to solve that particular problems, and then to reflect on the result that they get. The final stage come into play, and that is to interpret and evaluate the conclusions that they arrive. So these all are combined as mathematical reasoning, and both science and mathematics work in the same way, that not only memorizing or being to solve problems in textbook, but to link this into real life situation and transition of level of cognitive ability of students from lower level of understanding to higher level of understanding. And I try to, you know, pose some examples of learning goals in mathematics, starting from some basic learning goals to something a little bit more advanced. For example, like on the left-hand side, you know, the aim is to define, you know, basic set and concept, just to define. But, you know, moving forward is for them to be able to classify real-world objects into set representing variable relationships using Venn diagram and perform basic set operations. So you see, it's becoming more advanced. But to go further, not just only to be able to classify, but for them to solve contextualized problems, analyze the data, and justify the solution. This is, you know, the third level. Again, to be able to achieve the level that we want, students will have to collect the data, collect the evidence by themselves, and that is through, you know, mathematical means like survey, and then use the result to construct the mathematical argument, and then evaluate the validity of the conclusion. So I would like to come up to come to the conclusion part of the first bit of my talk, and that is learning triangle. So we have been talking about the importance of the learning outcomes, and we have discussed about the frameworks to formulate learning outcomes from PISA, both science and mathematics. And then we discussed that learning methods, you know, are the means for students to achieve that goal. And this can be varied depending on the goal or the destination that you would like to head forward. And the learning assessment has to be something that trace our students' learning evidence and their progress. So having this in mind, we can continue to the second part of my talk, and that is to do with three-dimensional learning. Of course, when we talk about three-dimensional learning, I get asked by many colleagues whether it's to do with reading this 3D image. I'm not sure if you've done the same thing. When I was young, my parents bought books of 3D images and let me look at the picture and try to see what is actually the image inside. I'm not sure if you can find it out. I think it's actually a picture of butterflies. Not sure if you can see that. This is for fun, but three-dimensional learning or 3D learning has nothing to do with the ability to see the picture from the three-dimensional image, but it's actually the attempt to bring three key aspects in the classroom. So when we talk about three aspects in education, some may think of the diagram on the left hand, which is the three domains of learning: cognitive domain, psychomotor domain, affective domain. But three-dimensional that I'm talking about is not actually these three domains of learning, or it's not just a general outcome-based education that focus on knowledge, skills, and the ability that students can link knowledge and skills together. But what I mean by three-dimensional learning, it's actually from the framework of next generation science standard. Next generation science standard is a set of research-based, up-to-date K-12 science content standard that expects what students should know and should be able to do. And for three-dimensional learning, there are three key elements here in the learning performance. So the first one, you may draw your attention to the blue one. It's practices or scientific and engineering practices. I will continue to talk about this. But not only practice, of course, students will have to learn some content, right? It is core ideas, or the orange one. And the green one as well. Not just only idea, not just only practices, but students will have to be able to see, cross-cutting concepts or the way scientists, view phenomena. For cross-cutting ideas is something that doesn't belong to a particular subject like physics, chemistry, or biology, but in every phenomena, students can use this cross-cutting concept to see the phenomena. So let me go into detail of this briefly. So start from disciplinary core ideas, or DCI. So disciplinary core ideas or content. But when we talk about content, it's not just the whole stuff in textbook, but it's the core idea that students will need to know. And this core idea can link to other ideas or help students, grow their understanding from, a foundational level to more advanced one. It can connect the idea learned in classroom to social context. And it has to be something teachable and learnable by students, not too difficult, not too easy. So the first element is core ideas. But the key to highlight is that not intensive content for students to memorize, but core ideas that can help students get deeper into that particular discipline. So proceeding from disciplinary core ideas, I would like to introduce cross-cutting concept in greater depth. So as I said, it's the ideas that cut across or skills that are important for all disciplines to adopt as the lens for them to view the phenomena. For example, like recognizing patterns or cause and effect. Cause and effect, I think, is crucial. It doesn't only belong to biology, chemistry, or physics only, right? It belongs to any circumstances, or structure and function. This is also relevant to different disciplines. When we talk about structure and function in biology, for example, you talk about the mouse, the structure and the function in the mouse to do with mechanical digestion, or structure and function of chemical molecules, structure and function in physics. These are cross-cutting concepts that students can adopt and apply these skills to view the phenomena. And uh, other dimensions, for example, like scale, proportion, and quantity. I think this, is numerical sense, mathematical sense that students will have to grow, right? So these are the examples of cross-cutting concept. But for today, I think examples that are used or cross-cutting concepts that commonly appear in school science would be cause and effect and structure and function. And the last one, I think this is the key for the talk today, and it's going to continue to the CER part that I will introduce later. It's to do with science and engineering practices, or SEP. So SEP can be understood as the way scientists work, or the way that classroom should be proceed. And I think, in the end, I would like to bring this as learning approach, or sequence in classroom, that if we follow this sequence in classroom, it's going to help our students to grow their competency, as well as the ability to use CER. So what are the key stages in SCP? So just imagine when students learn something, the first thing, or the first activity in classroom, is for them to ask questions, or the teacher pose some question for student to think about. So when the questions are asked, the following step is for students to develop and use models to represent their thought. The first one is to have question. The second one is to have tentative idea. We used to call hypothesis, or this one is to use tentative claim, or working model that they think can help answer the question. And after that, they have, the case, they have the hypothesis, they have the tentative model, they have the tentative claim. In the third phase, they are going to plan how are they going to carry out investigation in order to collect evidence to either support or weaken their tentative claim in the second stage. So after they get the evidence, in the fourth stage, they are going to analyze and interpret the data that they get. And then they're going to use some mathematics or computational thinking to make sense of the data, and also to present the data to others, or to convince others using this mathematical data or computational thinking, so depending on the context. And after they plan the investigation, carry out the investigation, get the data, analyze the data and use some mathematical analysis. Now they have, their own evidence, but it's enough for them to construct the explanation for themselves. And this is the sixth stage. Constructing an explanation here is key to, CR that I will talk about later. And then students, for middle school students, it can, stay in this level, but, for more, advanced students or high school students, not only constructing explanation by themselves, I think it is important for students to engage in argumentation. Of course, in argumentation, students will have to work in groups. Each group would have their own claim based on the evidence and reasoning process that they do, right? And then in the engaging argumentation, they will come and discuss and share their claim. And their claim might be different. And this, the channel for them to learn from each other. And sometimes the evidence from other groups can either support what the students get, or some argument will be totally different from what the students get, and then they can learn from these similarities and differences. And after they share this, argumentation session, the final one is for them to be able to evaluate the information, re-evaluate their claim, and then communicate the information afterwards. So we can see the progress of SEP in science. I will talk about math, of course, but just to again use the same example that I used earlier, not just only advancing to learning goals, but the more advanced learning goals that we talk about is actually include three dimensions of core-disciplinary idea, SEP, and cross-cutting concept. For the first one on the left-hand side, explain the concept is just one-dimensional. Engaging in discussion and articulate the implication, again, is also one-dimensional. But for students to be able to investigate a particular thing and then to be able to articulate the effect of X on Y, or how X contribute to Y. So this includes two dimensions. I try to use the color to represent, what three-dimensional learning is talking about. So the orange one is to do with core ideas, and then the green one is to do with the cross-cutting concept. And X contribute to Y is actually cause and effect. But for the last one, and it is something that I would like, all of us to continue to help our student teachers to be able to develop this form of three-dimensional learning goals. The same wording: conduct a genetic analysis to gather evidence and use this evidence to construct an argument that explains some particular concept of X that is going to influence Y. As you can see here, there is, I put the wrong color, sorry for that. For them to be able to conduct an experiment and construct the argument, this is supposed to be the blue letter. So the blue letter is the skills or SEP, right? For X influence on Y, it's cross-cutting concept under the category of cause and effect. And of course, the topic of genetics is core disciplinary ideas. So this form of learning goals is not only helping students develop competency according to PISA, but in fact, behind the development of this learning goal is actually three-dimensional learning that students can develop their own skills. And the SEP is basically for science, right? But something is similar, is applicable in mathematics as well. So there is another framework from New York State Next Generation Mathematics Learning Standard, developed in 2017, but later on revised in 2019. But this is, something quite similar in science. For example, like to make sense of problems and persevere in solving problems, or to be able to reason abstractly, to be able to reason quantitatively, and then quite similar to science, that is to be able to construct viable arguments and critique the reasoning of others. So that's argumentation. They can model with mathematics, like I previously mentioned. Science, is for students to be able to propose the model or the scientific explanation, translating something abstract to be something more understandable from others. Again, model can be applicable in mathematics, and for students to be able to use appropriate tools strategically. So basically, this one is to use the right formula or use the right tools in order to analyze the result. Apart from this, is to do with attention to precision, look for and make use of structure and even patterns. And the last one is to look for and express regularity. Again, repeated reason is the pattern that emerge. So what I would like to summarize here is that both science and mathematics, if we talk about the competency for students to be able to construct their claim, either scientific claim or mathematical claims, it is important for students to be nurtured with three-dimensional learning. Right. This is going to be, a final part of the three-dimensional learning before we proceed to the CER and the showcases that I have. But I would like to, use this one for you to do some participations. Again, I would try to have. I know that I'm talking, one way for long already. So I will try to have one activity for each of the topics that I talk. So here is the summary of the first step of change. What change has to be done is to change or to transform the learning goal, changing from one dimension to three-dimensional learning. An example for chemistry teacher, for one-dimensional learning, it is something like define the periodic table and explain, trends in atomic structure. So basically, for students to define and explain. But if we want to transform this into three-dimensional learning goals, wordings like, use evidence to construct an argument. So this is the key for SEP. The blue one is the practice, right? Use evidence to construct an argument. And this argument will have to be able to explain about periodic trend and their impact on chemical properties. You can see that the core disciplinary idea is periodic table, periodic trend, and the impact of X on Y is the cross-cutting concept that we are trying to cultivate. So I try to use the same concept, the blue one, orange one, and the green one in three-dimensional learning goals, transforming from the second one, from physics, define work, energy, power, and then explain their relationships using formulas and units. This one can be executed in classroom using lectures teachers can teach. But to transform this from just define and students explain to design an investigation to analyze energy transfer and efficiency in real world system, for example, using roller coaster STEM activity, and then construct an argument. Again, this phrasing reappear again. Construct an argument explaining how energy is transformed, and how energy is transformed is the concept of change according to cross-cutting concept. For mathematics, one-dimensional learning goal like identify geometric shapes and properties, as simple as that, to be able to identify. But to transform it to three-dimensional is to use geometric reasoning to model and solve problems. And then, the context can be added later on. Or another example in mathematics, instead of just finding probabilities of events, this is what I did in classroom when I studied mathematics in high school. But to transform this one to grow from one-dimensional learning to three-dimensional learning, it is for students to be able to interpret statistical data and then use probability models to make informed decision in everyday context. And the context can be medical risk assessment or anything at all that are concerned in the classroom. So this is the first practical way to start with transferring, transforming one-dimensional learning to three-dimensional learning. Before I proceed to the CER, I would like to take some questions, and also I would like you to do some, hands-on exercise. So if you scan on the QR code, it will direct you to a Padlet, and in the Padlet you can type your answers on that. You can use your mobile phone to work on that. And of course, I'm not going to ask you to work all of these, 4 learning goals. But the first learning goal, I would like to ask mathematics instructors to help me change from this one-dimensional learning goal to make it three-dimensional. The second one for chemistry instructors to change from just memorizing chemical symbols to something more active, to something more like three-dimensional. The third one for biology instructors, please help me change from recall parts of a plant cell and describe their functions, which is one-dimensional of course, to something three-dimensional. And the last one for physics teachers, transforming from one-dimensional to state the law of conservation, just state the law of conservation of mass and identify examples where it applies, to something else that be more three-dimensional. If I leave out like general science teachers or computer science teachers, you can pick any learning goals that you think work well for you, and something that you feel like you have an idea to make it more like three-dimensional. Can I just take some time, and I will change my screen to Padlet, and I would like you to scan the QR code first, and then just type what you think is the form of three-dimensional learning goal that you revise. Okay, that's making sense.
Please answer the.
Right, I can see.
Please answer the questions and then write it in the Padlet. Write it in the Padlet. Jadi saya dulu. Okay, come on, the person doing. QR code dia apa tak?
I'll go back. I'll go back to the QR code again, and then I will come back to this Padlet to see the idea that you proposed.
Right. So dia tunjuk bola. Okay. Scan the QR code again. Okay, so we have the 4 questions. One, and then nanti the Padlet ada 4 soalan ni, tukar to 3D learning. 3D learning. 3D learning. We have the mathematics, chemistry, and
Right. Okay, I can see the first response from a math instructor saying that ask students to analyze real life data such as exam scores, income, or survey to determine appropriate measure. Excellent.
yes,
So, so this one I can see math practice, and math practice is for students to analyze real life data. I can see cross-cutting concept that is, the data, how the data can determine appropriate measure. And if you can define, for example, like a particular um, idea, a particular concept that you want students to be able to analyze from the exam score income or survey, for example, like central tendency or correlation or mean comparison. I think that's going to even make this learning goal more concrete. But thank you very much. I think this is a great direction as students to analyze real life data.
Okay, participant lagi-lagi.
Right.
Sila respon dalam Padlet, nanti keluar je dalam Padlet tu banyak-banyak. Respon je. Respon, submit, nanti dia akan keluar dekat Padlet tu. Ada 4 soalan tu, ada fizik, chemistry, semua tu.
So I'm gonna give you 2 more minutes to work on this, and then I can come back and see how you post your answers, and I can give my comments back here in Padlet. But the final 40 to 50 minutes, I will continue my final part, which is about CER.
Okay,
Doctor, can you show back the question, please?
Sure.
Okay, snap the answer. Snap the answer. Snap the question. Snap the question. Okay, change the 1D learning to 3D learnings. Or 3D learnings. Example, the number 2, memorize the chemical symbols of common element in the periodic tables. Use the chemical symbols to show untuk kelas lebih kurang. Tak perlu jawab semua, jawab satu pun cukup lah. Mana-mana kalau yang rasa matematik boleh jawab matematik. For chemistry for the number 2, number 3 for biology lecturer, and number 4 tu number 4.
Right? Can I will just move back to Padlet, and then I can see some responses.
Yes, can.
Right. Okay. Thank you very much for all the responses. Right. This one from physics instructor. Changing from just only what we said to state the law of conservation of mass and design, identify examples like, so they can be design innovative structure or model that relates to conservation of mass. And then I like this keyword. I like this keyword. It's to construct an argument in explaining how X affected on Y. So the key is here. PISA competency is for students to be able to use data, to use evidence to construct their argument, construct their claim. So as long as you let students find out the evidence, to collect the data by themselves, and then use that data, use that evidence to construct their claim, that's going to help our students achieve what PISA competency is expecting. Right. I'll turn to chemistry. For chemistry, like students collect the height of their friends in class and then guide them to decide whether the data can be. Oh, this is mathematics, of course. Yeah, let's continue to read and classify into groups and ungrouped data. Then they find the mean, variance, and other measures of location and distribution. This is great. I think students can have math practice from here, uh, disciplinary core concept from here. But if you can, add some element of for students to be able to construct an argument something. If they get the data, if they analyze the data, what they can, claim, what they can argue from this. I think that is going to make this learning goal more, concrete. Uh, Let me read out one more. Define biology one. Define the model of parts of a plant cell and construct an argument explaining how parts of a plant cell can help plant to function effectively. Excellent. Something like constructing an argument from the collected data. So this is the idea. I'm glad you point this out. Design a model, or even they can go collect the plant specimens, right, from the field, and then use specimen from the field to construct an argument to explain something. Excellent. This one is excellent. Let me draw close by pointing out to G-Dragon. How about giving them a real situation question and ask the student to explain differences between, yes, okay, this can be done, to identify or recognize differences can be, foundational level for students to be able to proceed to more advanced skills like constructing claims. So thank you very much for all the participation and sharing. Sorry I can't read through all of them, but yeah, I can give you written comments afterwards. But yeah, let me spend my final part for 45 minutes, and then I can take some questions afterwards. Right. Okay. Oh, I will keep repeating myself that there are three topics that I'm delivering today. The first one is learning triangle. So learning triangle, I just encourage you to see the connection between learning outcomes, learning methods, and learning assessment, and introduce framework from science and math PISA competency as the framework to set learning outcomes. Because we agree together that when we change the learning outcomes, the learning methods are going to be changed. The learning methods will help our students to achieve that goal, right? And the learning assessment will have to be changed as well. And then after we know that changing the goal is important, we continue to discuss how the goals or the learning goals should be like. And then we do some exercise of three-dimensional learning, not just only disciplinary core idea. It has to incorporate practices, scientific practices or math practices in the lesson as well. But not only the core idea and practices in classroom, cross-cutting concepts, which occur both in science and mathematics, are essential part of the learning goal. And yeah, there are actually 7 aspects of cross-cutting concepts, but ones that we see quite often is cause and effect, or scale and change, for example. And now, if we change the learning goal to be three-dimensional learning goal, how are we going to achieve that three-dimensional learning goal, and how is it going to be linked to the CER approach? And this is the final part of my talk. So what is it, CER? CER is basically a framework used inside education, where students make a claim. A claim here is a statement or conclusion that responds to a question. So there must be a driving question, a question for students to provide some claim or provide some answer. But for students to be able to answer that, it's not going to be from, copying from the textbook, but it's going to be from collecting evidence. So the evidence here is, the data or observations that support the claim. And then to link evidence and claim together, there is the third element, or the R, or reasoning. So basically, reasoning is the logical explanation that connects the evidence to the claim. So in order to be able to do the CER here, there must be some way to help our students, continue the thinking process that requires the skill for students to collect the evidence and do some reasoning, right? So before
Sorry,
our
doctor,
students, yeah,
to interrupt.
sorry,
The slide is not moving.
it's not moving again. Oh no.
Okay.
Okay. Sorry for that. I need to share the whole screen.
Okay.
Right. Okay.
Okay, thank
Is
you.
that okay now? Right.
Okay, thank you.
So just to recap what I have just said. CER. C stands for claim. E evidence or reasoning. So claim is basically a statement or a conclusion that responds to a question. So there must be a driving question in the first place for students to be able to answer. But for students to be able to answer this, they will have to collect some data. They have to get some observations that support the claim. And in order to link the claim to link the evidence to the claim, that needs the reasoning process or the logical reasoning that combines both together. But before proceeding to how are we going to um, implement CER lessons in classroom, I have examples both in science and mathematics. I would like you to see different levels of CER expressed by students. So this is just something for us to see different levels of CR explanation. So the guiding question is how drinking water affects skin hydration. So this is a general question in daily life, right? How drinking water affects skin hydration. CER1, the first example, is something that I believe is the most complete in the level that the students wrote. So for the first one, the red sentence is the claim. The claim is a statement that answers the question, right? The question is how does drinking water affect skin hydration? And the answer is that drinking enough water helps keep the skin hydrated. So the claim is that drinking water matters. It keeps the skin hydrated. But why this person claims like this? The second sentence is that this person refers to studies. Of course, to be more profound, it has to be citation. But yeah, for students to be able to refer to this, I think it's acceptable. Uh, Studies have found that people who drink at least 2 liters of water per day have more hydrated skin than those who drink less. So you see, this is the evidence. There is evidence that two groups of people comparing, one, drink at least 2 liters of water, and the other one who drink less. And then skin hydration, hydrated skin can be compared. This is the evidence. But the claim and the evidence wouldn't be linked logically unless reasoning process, comes into play. Reasoning, connects two together by saying something like, this is because it or water helps moisturize skin cells, reduce dryness, and makes the skin look more radiant. And all together here is scientific explanation or CER. Reading like drinking enough water helps keep the skin hydrated. Studies have found that people who drink at least 2 liters of water per day have more hydrated skin than those who drink less. and this is because water helps moisturize skin cells and reduce dryness and make the skin look more radiant. So you see the connection of C, E, and R. But there are times that the CER element are not complete. CER2, CER2 is an example of a complete C, a complete E, but an incomplete R. It goes something like drinking enough water helps keep the skin hydrated. Refer to the same experiment to groups of participants who have at least 2 liters and who have less, and compare the hydration of the skin. But the reasoning is poor by saying something like this is because water helps improve skin appearance. So this is actually not linking the claim and evidence together. It's just out of nowhere and talk about how water can help improve skin appearance. What we need the reasoning process to do is to connect why drinking much water actually links to skin hydration. So unlike the first example, the R is complete. The second one, the R is a little bit vague or even unrelated. Or there are times when the evidence is actually confusing. Like, the claim goes like drinking enough water helps keep the skin hydrated. Right, that's fine. Studies have found that water is beneficial. What? By only saying that studies have found that water is beneficial, you just can't claim that water helps keep the skin hydrated, right? So now the evidence is not actually linking, doesn't serve to support the claim at all. Or well, I think this might not happen, but yeah, everything is unexpected, right? For example 4, refer to the same set of evidence. Study have found that people who drink at least 2 liters of water per day have more hydrated skin, right? And then the reasoning process is sophisticated by saying that water helps moisturize skin cell, reduce dryness, and make the skin look more radiant. But you see the claim. The claim is talking about, drinking enough water makes you smarter. How on earth, being smart is actually linked to the evidence and the reasoning process, right? So these are possibilities that the CER might not be complete. But of course, what we would like our students to be able to perform is for them to have a complete CER. And here is the possible ways to implement CER lessons in classroom. So included here are 3 different levels of CER lesson. So I start, from something foundational. The first one is introductory or basic understanding or simple application of CER. The second level is intermediate or scientific inquiry or structural reasoning. It's more advanced. And then the third one is what I really expect our classroom to come close to this level. And it is the what I call an intensive level or using argumentation and real world application. So let's focus on the first one, the introductory level. I think for middle school students or even high school students, or even our university students who are exposed to CR lessons for the first time, I think we can all start from the basic level. What the basic level can do is to first starting from introducing the CR concept. So basically, to introduce the CR concept is by telling, or defining what the C is actually is. The C is the answer, the conclusion to the question. E is the evidence, the support. The R is something that links evidence and claim together. And then after they get to know, some basic understanding of the concept of CR, let students analyze CR examples, like what we did earlier. Of course, I talk you through, but in class you can let students analyze the examples. You can provide them complete CR sentences and incomplete CR sentences, and let them discuss, the incompletion of the sentence. And then after they can analyze the CR examples, we can let them practice CR writing based on everyday scenarios like water hydration that I have said. That can be a starting point, or it can be something even more simple in your context that you think students may be engaged to that particular topic. And after they are familiar with CR writing based on everyday scenario, they can proceed to something more specific to the subject. So here is the stage where you can proceed to the second level of CR, or even the third one. So that is to apply CR writing in specific subjects, right? And then the last one, before I talk about the second level, is after students know how to write, they need to know how to improve, right? And the way for them to be able to improve their CR writing is for them to be able to see the rubric that CR can be measured in each of the dimensions, so that they know, oh, it's the claim that they are having difficulty, or it's actually the evidence that they are having difficulty, or the reasoning process that they are going to improve. I will show you the rubric that I draft, and then you can, if you think it makes sense, you can you can use that. Let me continue to the second one. The second one is to do with intermediate level. I want to link this back to the SEP, right? So now what I show on the screen is the 8th step of SEP. So we just remind you that the 8th step, the first one is asking question. The second one is developing tentative claim using models. The third one is to plan and carry out the investigation, and then analyze the result, analyze the evidence, and then use some mathematics or computational thinking to make sense of the data, and then construct explanation using the evidence, of course, and bring in the reasoning process, and then engage in argumentation in number 7, and number 8 to evaluate and communicate the information. So there are 8 steps. If you only focus on step 1, 2, 3, 4, and 6, this can be an intermediate level, starting from asking questions. So this is what I would like to encourage: asking questions, posing guiding questions for students to discuss the tentative ideas, and then let students develop tentative models, which is SEP number 2, and then plan, investigate, interpret the collected data. These are SEP 3 and 4, right? Number 5 is actually using mathematics and computational thinking to make sense of the data. For the intermediate level, some teachers said that okay, they can skip this because it requires skills in mathematics and computational thinking in classroom. But if your students can do that, why not? But for the intermediate level, okay, this can be omitted. And then the last one, the last step for the intermediate level is to write CR-based explanation. So it stays at number 6. It doesn't go to number 7 and number 8. So basically, there is no argumentation. But if your students are familiar with, argumentation session, they think the classroom is positive enough for them to receive feedback and then to discuss openly with their friends, it can continue to level 3 of CR, that is the intensive level. It incorporates argumentation and real-world application in there. So basically, this is a faithful follower of the 8-step SEP or math standard, as we discussed earlier. And why the 8-step SEP can actually help students achieve, the competency in formulating claim using evidence-based reasoning. As you can see, what I try to analyze here, when we ask students questions and then they develop the tentative models, right? So this becomes the tentative claims anyway. If they claim without proof, it's the hypothesis that they have in the first place, but it's the starting point for them to continue to plan how they are going to carry out the investigation and collect the evidence. So number 3, planning and carrying out investigation for me is the way for students to, obtain the evidence for them to make use to support their claim in the future. After the students carry out the investigation, they get the data, they analyze, they interpret, they use mathematics and computational thinking to make sense of the data. They draw theoretical frameworks that they know in order to make sense of the data. And this is the reasoning process. So starting from tentative claim, having evidence which can be evidence that support or evidence that can weaken your tentative claim. Doesn't matter. Students can reformulate their claim so that in the sixth stage, when they combine the evidence and the claim with the reasoning, they can construct an explanation. And this is the C, the claim that comes from evidence-based reasoning. And if the students are ready to continue from level 2 to level 3, from intermediate to intensive CER, right? Teachers can incorporate argumentation, which is number 7. So number 7, basically students will be able to learn from the other groups. Students will see the evidence of the other groups. Students will see the claims from the other groups. And then they can do some, ideas exchanging, which can allow them to arrive at, evaluating their claims and perhaps the revision of their claims in the end. So I just want to summarize that the CER approach is actually a shorter version of science and engineering practices according to the NGSS. And there are 3 different ways for you to do CER. So basically, the first level is to just focus on the ability to write the CER. And the second one is for them to be able to do the intermediate one, for them to be able to think of tentative claims, find evidence to support their tentative claims, reasoning to connect the evidence to their claim, and that's it. Or to proceed to the last one, that is to do argumentation in order to get a wider range of evidence, and they can have opportunity to revise their claim in the end. And the same is true for math practices. So for math practices, basically is to use reasoning, is a claim, evidence, and reasoning in the process as well. Like, after making sense of the problem, student can reason abstractly and quantitatively. This is reasoning, right? And then you see wording like they can construct viable arguments and critique the reasoning of others. This is the claim. And there is a range of approaches for students to use mathematics in order to collect evidence, like, model with mathematics, use tools statistically, attend to precision, or look for structure, look for patterns. So these are the combination of, evidence and reasoning that leads to claim. And in the end, what a CR classroom is going to be like. The CR classroom is going to be something like this, that students will have their model on the left-hand side. This is from a tool called Sage Modeler. Sage Modeler is a tool, a computer-based tool for students to, translate what they think in their mind, abstract concept, into something more observable, into something more concrete for them to present their idea. It's very dynamic. A student can change, the dynamic from the model in Sage Modeler. But this doesn't have to be done using Sage Modeler. It could be mind mapping. It could be pencil paper drawing, as long as students can, choose a form to represent their conceptual understanding and make it seen by others. So this is one of the learning evidence that students will produce. And apart from this, it's going to be something like on the right-hand side, which is the record of CER written explanation. So what I normally include in the CER written evidence or explanation is to have students write the driving question, what question they are, trying to answer, what is the claim that they have, what is the evidence they use. If there is one more type of evidence, you can specify that for the ease of the students to use. Like, I have evidence 1, evidence 2, and evidence 3 for students to just record the data that they get. And I have, a larger space for students to draw the connection between claim and evidence, like, reasoning 1, reasoning 2, and reasoning 3. So basically, reasoning is the scientific theory or logical explanation that connects evidence to the claim. So this is the way for teachers to get learning evidence. And assessment can be done using this, or if you are interested in doing research seeing the ability to construct CER explanation as dependent variable, this can be something that you can qualitatively analyze or quantitatively analyze later. So, and how are we going to analyze this? It's on these two slides. So slide 44 is the rubric that aligns CER with PISA science competency. And on page 45, slide 45, I remodified it to make it fit math competency. So my background is biology, so I have been working on science competency, but I try to adjust, the rubric to this seminar, this discussion in particular. So if you find something useful, please use it. But if you find something doesn't make sense, you can just let me know and revise in your own version. So let me start from the PISA science rubric of CER. As you can see, the rubric is analytical, having the criteria of claim on the left column, and I link this claim to the first competency of science PISA, and that is to explain phenomena scientifically. The E criteria or the evidence is actually linked to the second competency, which is to construct and evaluate design for scientific inquiry. So the design here is the way to get the evidence, right? And the last one is the reasoning. The reasoning is to link the evidence to the claim using theories, using, scientifically defensible information, right? So I link this one to the third competency, which is to research, evaluate, and use scientific information for decision making. Having these three criteria linked to the three competencies of business science, it can be displayed in 4 different levels, starting from emerging, developing, proficient, and then advanced. So basically, emerging is unclear claim, little evidence, little to no evidence, or no reasoning at all. For the developing process is it's the category of yes but. Yes is something like the claim is clear but lack precision. There is some evidence but it is incomplete, or there is some reasoning process but it doesn't link claim and evidence sufficiently, for example. The third level is proficient. Proficient is something that I expect students to perform in classroom actually. It doesn't go beyond, the definition of CER. Like C, the claim has to be clear and the answer has to be correct. It's as simple as that. It has to be correct and correctly answer the question. And if it has to use, the terminology has to be used correctly. For evidence, is use reliable, credible scientific evidence. It shows the understanding of how the data support the claim. And for the reasoning process is the clear link between the evidence and the claim, appropriate use of scientific principles, and the link is done logically and coherently. So this is what I actually expect students to perform in classroom. But for the fourth level or the advanced one, I think this is beyond expectation. Students can do a lot better than what we expect. So I'm not gonna focus on this, but you can you can read it in your leisure if you think your student can go to the fourth level, which is very exceptional. But if you want to stay to the satisfactory level or level 3, I think that is an achievable goal. And slide 45, it's slightly changed from science to math. For example, like C, I try to make it generic, like provide precise answer to formulate mathematical to the formulated mathematical problems. So the claim has to be for emerging, the claim is unclear, but for proficient, the claim has to be clear and mathematically sound, and of course it has to be directly answering the question. Moving on to E, emerging is something like provide no evidence. So I try to keep it general. Developing, like yes, but, right, provide some evidence, but it is not very clear, or the evidence holds some form of inaccuracy. But for proficient level, is using correct operations, calculations that arise at the correct form of evidence. And for reasoning is to interpret and communicate the result, right? For emerging, there is no reasoning at all. But for developing, it's a yes but category. So there is some form of reasoning, but the link is weak or inaccurate. But for proficient, everything is fine. Everything is as expected. There is a clear link between evidence and claim. But for advanced, it's something beyond expectation. We hope our students will get there soon. But proficient level is something that we would like to achieve for the time being. Now, I would like you to have a think. I don't think this one. I'll ask you to turn on the microphone to respond to me. But I would like you to have a think with me. If you are going to apply the two rubrics, or if you can't remember, that's fine. You can go back to slide 44 and 45 later. But we can have some feedback for the students, or for students to learn how to feedback themselves using the rubric. On the left-hand side is an example of a mathematics scenario. For example, we have the guiding question asking, what is the probability of getting hit when flipping a fair coin, right? Mathematics instructor will say that, it's 50% chance, right? But what if the student writes something, the red letters is something the student write. If you flip a coin, there is a good chance it will land on heads, because heads and tails are the only two options. So you see, this CER statement has room for improvement. And my critique is that the claim is somewhat correct, but vague. Like good chance, what is that? It must be more precise mathematically. So for me, the yes, but here is something in the developing level. And the evidence is actually acknowledging two possible outcomes. But it's a yes, but again. But it doesn't say probability 50% chance at all. And the reasoning, it lacks. In fact, this one, the mathematical justification is actually lacking. I don't see the reasoning. So if I mark here, the reasoning criteria I would give emerging. It is in the emerging level. So the claim I would put developing, evidence developing, the reasoning I would put emerging. Turning to science, the one on the right side, what factors determine whether an object sinks or floats? And the answer, or the CR statement of the students goes something like, heavier objects sink in water, but lighter objects float. Like a piece of wood compared to a metal block. Okay. Now we can see that the claim is heavier objects sink, lighter objects float. The evidence that we get is the comparison between a wood and a metal block. But I don't see the reasoning again, which is similar to the math response. So the claim is in a yes but category. So the claim is somewhat clear but lacks precision. And the lack precision here means that weight alone doesn't determine the floating ability of the object, right? So the claim is there, but it is incomplete. For the evidence, it actually provides basic comparison. It's a yes, but again, but it doesn't actually mention density and buoyancy. It only points out the observable phenomena, but it doesn't draw the submicroscopic explanation. And this is because the lack of reasoning. The reasoning is weak because it doesn't actually explain anything from scientific principles. So reasoning is actually in emerging level for me. Right. This is the way I apply the rubric to analyze the statement. Right. And now I would like to spend my final part to walk you through the examples of CR lessons, one in science, one in mathematics that I developed with my students, and we have been using these two activities in classroom. And I will end the final example by pointing to resources that might be useful for you to rely on in the future in case you want to find resources for developing or using as showcases for your own students. So the first one is uh, a science CR lessons. And as you can see, I'll also click the next slide as well. 47 and 48 include 8 steps of SEP. So that means I'm using the third level, the intensive level of CR lessons. So what did I do in this classroom? The first one, starting from asking question. Who actually asked the question? The teacher. The teacher. The teacher is actually. The teacher is actually. Oh, um, my 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 earphone is actually running out of the battery. I'm not sure if I'm still audible. Can you still hear me? Can you still hear me?
Yes, yes.
Okay, all right, okay. Oh, the earphone on the right side is actually running out of battery. Okay, thank you for that. So, who is actually asking the question is going to be the teacher. The teacher is the person who starts asking the guiding question, but students can continue to ask, sub-driving question as they see appropriate. So the question is something like, what factors determine whether an object sinks or floats? And after that, after I asked the students the question, they start developing their tentative models. So they discuss among them using Search Modella that I introduced to you. But again, it can be some other tools. It doesn't have to be Search Modella. But Search Modella is very, very useful for me because it can help translate what students think in mind in the abstract level and make it more concrete. After they have the tentative claim, some would claim that density effect, some would claim the buoyancy effect, some would claim that volume effect, some would even claim weight only effect. Then whatever they claim, they have to plan and carry out in order to collect the evidence. So I provide them, with clay, water, salt, and paper clip. So just for them to decide how are they going to test out their working idea, their tentative claim. And then when they get the result, like in the stage 4, you can see, floating clay. Normally, when you put clay in water, it sinks, right? But when you change the volume, you change the shape, then it can make the clay float. So students, we have to analyze, we have to bring in reasoning process to make sense of it, or for the paper clip, if you put it in water, it normally sinks. But if you put it gently or use some other assistant tools like paper or another clip, you can make it float. So if you want to explore this, yeah, it's something fun. You can try it your own. And then students will get the evidence. After they get the evidence, they will have to come back to the Search Modella in step 5, where they can add some data, whether factor X positively or negatively affected the state of being sink or float, something like that. So, and use this mathematical thinking, use mathematical models to make sense of the phenomena. And then in step 6, they are going to construct the explanation. And of course, the explanation here is to answer the guiding question: what factor determine whether an object shrinks or floats? So in step 6, students will have their own the explanation emerge from their groups, right? And if I use 7 and 8, and 7 is to engage in argumentation. Students will learn from other groups as well, and different groups may come up with different types of evidence, and some evidence might be overlooked by a particular group. For example, it's like the process that students see as more pieces of jigsaw for them to connect a bigger picture, and then they can see the reasoning process as the other group are presenting as well. And then if what the other groups are presenting is actually supporting their claim, okay, they can come to verify their claim. But if something is actually weakening their claim, they can come and reevaluate their information and then rewrite their revised claim below of the page. So this is the flow of the activity in classroom. As you can see that you start by asking question, letting the students do some prediction and then find the evidence to support their claim and then report their claim before doing argumentation and revise their claim. Right. On 46, 49 and 50, as you can see, again, we are following the 8th step of SCP, and the context here is about mathematics. So what we are doing here is that we provide students with data set. The data set here is about the performance of 2 hotel managers, and we ask the guiding question: what is who is the best candidate for contract renewal based on the performance data? So we give a scenario that the students are hotel manager, and there are 2 people that they are going to continue the contract. You can choose only one, and here is the performance data. How are you going to decide and who are you going to renew the contract? So after asking the question, students start discussing to develop their tentative ideas, right? So as you can see here, I'm not sure if you can, but I asked them to list out possible criteria for making the decision. This can be the revenue that they generate. This can be the satisfaction. They see the data set, but they haven't analyzed yet. But they use the data set to form tentative ideas. And then number 3, after they know what they are expecting to analyze, right? They can continue with planning and analyzing. And on the 4th stage, you can see the result from Excel, from Google spreadsheet, analyzing the result, and then they have mean comparison. They do some t-test. They have p-value. They have correlation to make justification who they are going to renew the contract. And then number 5, they can use the data, of course, to reconfirm their claim, right? And then write their claim before engaging in argumentation, where they can see what the other groups are considering. And this one is so engaging because different groups focus on different areas, focus on different parts, and then they even come up with 2 different sets of answers. Some would decide to renew the contract with person A, but the other one with person B. So after they exchanging their ideas through argumentation, they return to their final decision, the decision report in stage 8, where they evaluate the information. So these 2 are the activities that we develop, we use amongst the Thai students. But here is the final part. I will go very quickly. It's the online resource, free access, and research-based development. So you can find a range of activity like chemistry, water quality, which is representing chemistry, health in our hands, which is representing biology. You have something like interactions, which show example of physical science in this one. So you can turn to this. You can just Google open 3D science or Concord, like the one that I capture here is from but I the keywords will link you to the same material. And then what it has here, I just show an example of the activity from biology subject. It's actually showing how CER lesson is actually developed in a linear fashion. It doesn't, it doesn't, finish in one lesson. But for us that we are implementing the CER lesson in Thailand, where we have, extensive content in classroom, we can't actually do a long-term commitment to do CER, in a sequential manner. but we develop, single activities for students to implement. But this one, it's, developed in a sequential manner, 7 learning activities altogether. And then, from the first activity to the 7th activity, it would take the whole term to cover. And in each of the lesson, in each of the activity, it is guided by driving question. And the situation here, is the case study of Monique, who is a diabetic patient. And then, her case is going to be studied and reviewed by the student. And this is an example of the first study, the first learning activity. I will use the diagram. The first study starts from asking question. The question that they ask is what controls Monique's health? This is the first question. And then students in the group will develop, sub-driving questions. Some may ask how the feeling affect, or some would ask how family affect, or food, or exercise, or could be anything, right? After, the guiding question is asked, the students start, asking sub-driving questions that might contribute to the guiding question of what controls Monique's health. And then it continues to the second phase, which is to develop a tentative model. They don't use sketch model, they just use diagram and show the factors and the effects that may arise. After they develop the tentative model, they start collecting the evidence through planning, investigating, collecting the evidence. And then when they get the evidence, will be used in conjunction with reasoning process. And this will help them either, come up with that claim that support the initial claim, or another claim that is, different from what they think in the first place. And then in the end, they will get, the final claim based on evidence reasoning. And then they can continue to do argumentation by presenting the idea and evaluating the information afterwards. So that's the end of my talk today. I hope that I can give you some flavor of the importance of 3D and CER. So the CER, I introduced to you 3 different possibilities to implement it in classroom, starting from something basic to something intermediate, which is to omit one of the SEP practices. But what I encourage you to do is to follow the 8 steps of SEP, that's the CER approach that I would like to recommend. And doing the CER approach in classroom, it will help students see the interrelation of 3 dimensions of the learning. But CER would be too much to do in classroom if our learning goal is just to explain, right? So I introduced to you the concept of learning triangle, that we change the goal, change the learning goal. If the learning goal is changed, change in what way? Towards 3-dimensional learning according to NGSS is going to, guide the way that classroom should be changed. So I'm not sure if any questions that you would like me to address, or any reflection that you would like to me to clarify at the end of the presentation.
So participants, is there any questions? So doctor, I guess there are no questions.
All right. Okay. So I hope I hope you can apply what is introduced this morning into the activity in the afternoon. So all the best for training your student teachers to use CR in classroom in the future. And thanks again for having me today. And hope we can continue to work together. If you have anything at all, the QR code on the first page of the introduction will provide the contact to my email. Thank you very much.
Okay, thank you to Assistant Professor Dr. Pratchayapong Yasri for the great sharing just now. Thank you also to the participants for the active participations just now. Hopefully this sharing will be beneficial to everyone and enhance our understanding on CER. Now we will take a lunch break and continue our second sessions at 2 p.m. All participants, please be back here at 1:50 p.m. in respective PLC group as listed in document that we shared. And it's convenient if each group could bring together any sort of device such as laptop or notebook. Lunch has been prepared for all the participants outside. So thank you for the first sessions. Thank you again, Assistant Professor Dr. Pratchayapong Yasri.
Thank you very much. All the best. Bye. Thank you. Thank you. Thank you. Bye bye. ครับ สวัสดีครับ
Testing. Makanan tu dah sampai dah tu, dalam proses dah set up lah. Sabar sikit lah. Maaf, kita kelewatan. InsyaAllah, see you again at 2 o'clock, 1:50, jumpa sini.